Hello, I'm Michael McLean, Professor of Ecohydrology at UNESCO-IHE, and welcome to Unit 3. This week we're going to be focusing on situation analyses. You will have learned a fair amount now about some of the basic principles and ideas of environmental flow assessment, and now we're going to start moving toward, at least, the application. And over the duration of this course, you're going to learn a lot of methodologies, concepts that are common and apply across many different kinds of environmental flow assessments. But due to changes in geography, biology, demographics, and the like, each environmental flow assessment is also unique. Each environmental flow assessment is developed in a unique context. A biophysical context, a socioeconomic context, a sociopolitical context as well. So this week we're going to focus on gathering and analyzing the information necessary to place your environmental flow assessment correctly in the larger context and hopefully to therefore improve the outcome of the assessment. So our learning objectives first are to understand the larger biophysical, socioeconomic, and administrative context influencing our assessment and implementation. And then to learn a little bit about some of the tools and approaches to analyze the interrelationships between the different factors and to consider them in planning of environmental flow products. Every project is developed in a dynamic socio-political environmental system with a history, with a future, with a momentum. It's essential that we, the practitioners, we, the researchers, understand that context and place our work within it. So, what is a situation analysis? I'm going to be relying on documentation produced by IUCN, and you'll find linkages to that documentation in the reading materials and also the text beneath the slides. But it is a situation analysis is a scoping process. It's one of the first efforts that we undertake in order to begin pulling together and analyzing information relative to our environmental flow assessment. And it's a scoping and analysis of the broad context or external environment in which the project will operate. What are some of the components of it? Certainly it starts with an analysis of who are the key stakeholders and also the larger community or the larger group of stakeholders that should be considered over the course of the project. It also includes an analysis of the state and condition of resources and people. You'll see that we'll focus on both the condition of people in the basin as well as the condition of resources, water in particular, but also related resources. And finally, identification of what are the major issues and an understanding, therefore, of where environmental flows serve as a response to certain issues. We'll get there as we go forward. What are some of the methods used? Well, situation analyses generally do not involve the collection and generation of brand new data. Usually trips to the field to sample for fish and the like are not considered part of the situation analysis. It's usually more of a literature-based review, information that's already out there and has already been generated. But it does involve communicating with, doing interviews with stakeholders, even organizing workshops to bring stakeholders together to identify and prioritize the most important issues. We'll find that mapping, the visual representation of information in maps, is a very important tool and methodology inside situation analysis. And then there are a number of different frameworks for simple analyses, and I'll just present briefly one at the end, pressure state response framework, which helps us to identify the causal relationships, the cause and effect of what are the pressures that are being exerted on this system, what's the current state of the system in relation to those pressures, and what are the possible responses to address the issues. A good place to begin in any assessment is to understand what is the legal and institutional framework in which your environmental flow activities will take place. Now, in some cases, we're fortunate, and there's an explicit law at the level of a nation, of a province, of a state, whatever it might be, that calls for the determination of and the protection of environmental flows. But very often, you'll find that the need to preserve environmental flows, the idea of conserving ecosystems, aquatic ecosystems, which requires environmental flows, is embedded in other laws. So the case for environmental flows, the legal enabling environment may need to be identified by exploring a variety of different laws. And very often there are at least laws within the environmental portfolio of the country. But I'm going to give one very straightforward example for you, and that is an example from Kenya. In 1992, Kenya developed a new Water Act, and in that Water Act, they established a new institution, the Water Resources Management Authority. And they gave the responsibility to that institution of planning, allocation, apportionment, assessment, and monitoring of water resources. And clearly indicated among those the strategies required to achieve that objective was the call for the National Water Resources Management Strategy to be developed, which includes prescribing the requirements of the reserve for each water resource. The reserve here is the critical term, and in the law we can seek a definition of the term reserve, and this is what we find. That the reserve in relation to water resources includes two components. The first component is the satisfaction of basic human needs for all people who are or may be supplied from the water resource. This is an approach that's applied in countries, and especially southern and eastern African countries, where a proportion of the population still relies on surface water, direct access to surface waters for their domestic water supply. So there's a requirement that enough water be left in the river for them to meet their basic needs, which is 25 liters per day per person, thereabouts. But the second component of the reserve, which is usually a requirement of considerably more water and components of an environmental flow regime, or excuse me, components of a flow regime, Part B within the reserve calls for protecting aquatic ecosystems in order to secure ecologically sustainable development and use of the water resources. So this is the definition of, or close to the definition of environmental flows that is applied very widely in the world. So we can see that in achieving the reserve in East Africa, these basic human needs will be met, but also the objective of preserving the vitality of aquatic ecosystems will be met. Now, next we want to look at the administrative structure. And in this case, this is the structure focused specifically within the Ministry of Water and how they divide responsibility for dealing with provision of water services on the right. But on the left of this pyramid, showing different institutions and levels of institutions, either a National Water Resources Management Authority that is then composed of multiple regional offices that are each responsible for particular river basins. We find our key stakeholder, that stakeholder that we just saw in the law has responsibility for determining and protecting the reserve and thus environmental flows. We find them here. So we've identified first the overall structure of the agencies, the offices involved in managing the resource, and we've focused in on that critical partner, that critical responsible authority for environmental flows. And they are, of course, operating in an environment that involves many other government agencies at different scales, and a whole world of NGO activity and private sector and community organizations. So for us, this is a key stakeholder, but we know that they're operating in a larger, in a larger system. So let's go next in the process of a situation analysis. Although some of the things that I'm mentioning, they're actually happening in parallel and not necessarily one after the other. But so far, we've begun with some of the most important first questions to ask. What is the legal and institutional framework for the project that I want to develop? And I've identified my key stakeholder, which is actually shown at the bottom here. The key stakeholders in general are those with direct responsibility for the implementation of activities that are closely linked to and perhaps even overlapping with our goal in environmental flows. But there are other kinds of stakeholders that need to be identified in the process as well. This is also a breakdown provided through IUCN, but widely applied across many projects and sectors and organizations. So we can distinguish between primary and secondary stakeholders. Those primary stakeholders are those who depend most directly on the resources and are likely to be affected by any changes. And they're also the government agencies that are directly responsible for management of those resources. So this would include the water users in the river basin where we're planning to develop our project, and also the government agencies directly responsible for the management of water and those closely related resources. And then there's a world of secondary stakeholders that are not directly dependent on the resource. They may not necessarily have direct responsibilities for the management of that resource, but they're interested. They're interested because of the ramifications for health or security in communities, the welfare of people living in the basin. So NGOs and community-based organizations often fall into this category. Important stakeholders to be aware of, and also to find a way to involve in your project. And that process of determining the strategy for involving different stakeholders and the level of involvement can be captured through a simple analysis of stakeholders in the basin and the collection of information about each of those stakeholders. Now, this is a matrix that is useful for collecting information about the responsibilities of the different stakeholders, stakeholder organizations, what their importance is in the process, and also what their level of influence is. This combination of, or this balance of importance and influence is fundamental to our determination of exactly how we will engage those partners and how much effort as well we put into that engagement. So upon stepping through the different stakeholders that have been identified in the basin, identifying these characteristics of each, those data can be analyzed in a simple matrix such as what is shown at the bottom of the screen here, the importance influence matrix. And you will see that there are 4 different categories that can be ultimately decided upon. Well, let's just look at the axes quite quickly. So the y-axis is showing increasing level of importance. The x-axis is showing increasing level of influence. Therefore, we have category 1 stakeholders who have high importance but low influence. Now, these are often our local partners. Often they're the beneficiaries. They're those local people and communities that depend on the resource and will be impacted strongly if there's a change in the availability or the quality of that resources. But they may have little influence or power on their own to affect change or to control that resource. Category 2, partners or stakeholders are those with both high importance and high influence, right? Both of these are categories of stakeholders that we're going to want to engage directly in the project. And of course, very often our key stakeholder, in the case of Kenya, the Water Resource Management Authority, falls into this category. A great deal of importance, and the importance of the change of flow regime is high in their sphere of interest, as well as an influential agency that has real responsibilities for managing that resource. They issue the permits that allow water abstractions. And then we have categories 3 and 4, which are stakeholders for which the issue of environmental flow is of lower importance, and they may either be highly influential organizations that will want to keep informed of what we're doing, make sure that they understand, try to avoid any misunderstandings that might lead to a negative intervention by that influential stakeholder. And then, of course, there's a category of stakeholders that are both not particularly interested in the topic of environmental flows and also of relatively low importance. And that is a category of stakeholders to just simply keep informed in a simple fashion over the course of the project. So with this identification, with this classification, categorization of the different importance and roles of stakeholders, we can develop a strategy for engaging them in the process. And also open those channels of communication that may also be important for the collection of information that will be important to the next stage of our analysis. So let's move into that. Stepping through a number of topics that are relevant in a broader context. They are the setting, the context in which our environmental flow project, our environmental flow activities will be developed. And we begin by just getting to know our basin. So a basic basin description, learning something about the demographics of the basin, its area, its length, what's the topography like, a sense of the climate, information about the land use, land cover, and how that's changing, information about the population and how it's changing, what countries might be incorporated into the basin, especially larger basins, what are the jurisdictions within it, big cities, infrastructure, roads, basic information that allows us to become familiar with this basin. I mentioned earlier that maps are an important way of presenting information. And so I'm going to show you a number of maps, and we'll move through them relatively quickly. But they're primarily maps of the Orange Senku River Basin in southern Africa. It's incorporating South Africa itself, Namibia, Botswana, Lesotho. But there is a river awareness kit that provides a wealth of information, well presented both in text and visually. And there's a link to that site, the information about the Orange Senku, at the bottom of each slide, and you'll also find it in the text. So I encourage you to go and explore this river awareness kit yourself. But we'll use it now to just highlight some of the important characteristics. So we're getting to know this basin. You know, we can see the outline, we can see a bit about in this case, the river drainage network itself. This image shows in different colors some of the major subbasins, some of the major tributaries, and also shows where large reservoirs are, and we can see where the population centers are. And we can see especially this very important population centers of Johannesburg and Pretoria, South Africa. This is, of course, the same basin. We'll see many images of it. But in this case, what we see is we now see the national borders between Botswana, Namibia, South Africa, Lesotho here on the eastern extreme. So those national borders perhaps indicate for us changes certainly in the political and the institutional frameworks in which we'll be dealing with. The laws in the countries regarding environmental flows might be different. We can also see shading that indicates different ethnic groups that are represented in the basin. And the differences between those ethnic groups may result in different, cultural perspectives and ideas about the importance of ecosystem protection and environmental flow. So we want to be aware of when either political, institutional contexts may change, as well as cultural changes that might influence the project that we're developing. This is a map from 1960 that shows population in the basin, and it's actually a fairly low population in much of this basin, the Orange Senku, but we can see that the population centers tend to be concentrated in this subcatchment here, And this is a 1960 version, and with as many data sets as possible, we want to put them in motion. We want to understand how they're changing through time. So we go from 1960 to the year 2000. So 40 years later, what does the population density look like? And as you look, we've seen an intensification of population throughout this entire region of the basin, and in a spotted fashion in other areas, in Namibia in this case. But we can really see the buildup of pressure around Johannesburg and Pretoria. Whenever there's a concentration of population, we can expect a concentration of demand for water and other resources. And we're also looking for points in the basin where there might be major projects, right, like major irrigation schemes, that might also have an influential, a strong impact on the resource itself. Now, I'm not going to go through a lot of slides about conditions of the people, but some of the characteristics that you might look for is information about the health of people in the basin and how that might be related to water quality and the ability of ecosystem services to assist in maintaining higher quality water for people. The level of wealth, the economic welfare of people in the basin is going to be important in many ways to our work. What's the level of knowledge? The level of education among people, and therefore their perceptions about some of the technical aspects of this study, and also the importance of ecosystem services. I've already mentioned cultural differences that may play into our efforts, information about community, information about equity. In the text below the slide, in the text that accompanies the slide, you'll find additional information on each of these topics. So I encourage you to have a look at that. But I want to now go through information about resources in the basin, certainly focusing attention on water itself, and water as a resource to be extracted from the system, and water as a resource to be used in the system in the case of hydropower, but also looking at some of the related resources: forests, soils, and arable land, biodiversity and wildlife, fisheries, minerals, a focus on water as a resource, but also an exploration of related resources that have an influence, one way or another, on water resources in the basin, because water is incorporated and woven into all of these other resources and the uses that we put them to, so that we can understand the multiple linkages. So when it comes to water resources, we want to look at different components of the water balance to really understand how water is moving through this system. So we want to begin with rainfall, pay special attention to surface water, but not neglect groundwater, because the two, surface and groundwater, are interconnected, and changes in one will influence the availability and the dynamics of the other. And then we want to focus attention on water use in the basin. Where are people getting their water from now, and how are they using it? So let's begin with rainfall. And rainfall, of course, is only a fraction of rainfall runs off as surface water in the basin. So, on first thought, we might decide, why, as with our interest in environmental flows, should we pay much attention to rainfall? But the reason for that is just that the proportion of water, in this case in the global water cycle, but this cycle could be adapted for our Orange Senku Basin or any other basin. In any case, we're going to find that a large part, and usually the largest pathway of water moving through the hydrological cycle in a basin, is from rainfall, which falls onto soil surfaces and is transpired or re-evaporated back to the atmosphere. It's especially that component that is transpired, that water that supports the growth and vitality of plant life, that we want to focus on, because of course agriculture can be included in that category. And agricultural water use has a big influence on surface flows in rivers. And to the extent that we can optimize and improve the productivity of crops using rainfall, we're able to reduce the pressures on surface water. So investigate first rainfall in the basin, and those data will become relevant as we look for responses to some of the conditions that we're facing. So here, back to the orange senku, is an illustration of rainfall across the basin. And we can see that there's a strong gradient with higher rainfalls to the east and much lower rainfalls to the west. Remember where we had our population densities, which tend to be in the areas with higher rainfall. That makes sense. You might have noticed before, too, that in this subbasin, the rivers were identified as ephemeral, which means they're seasonal or they're intermittent. There are times when the river channel is dry, periods of the year when the river is dry. And that also corresponds with our observation here that this is an area of much lower rainfall relative to this area, which is probably supporting the largest part of the flows. And also, this is a good point in the process to begin identifying where the stations are, the hydrometeorological stations, climate stations, perhaps just precipitation gauges in the basin. Where are they? Under whose jurisdiction are they? Who's responsible? And what are the durations of data? And how do we access those data? Because at this point, we're also mapping what's available to us to be used later on in the process. So begin paying attention to where those stations are and who's responsible for them and what years they cover. Now let's turn our attention to surface water. This is a map of the orange senku that shows the figures that are shown, and for each of these subcatchments is the amount of annual runoff, the volume of water flowing out of that subcatchment per year in million cubic meters. And we can see that the highest amounts of runoff are coming from the area with the greatest abundance of precipitation. This is also the area where population density is highest. We can see a concentration of demands in this particular area. And now I've also superimposed on here discharge stations, river gauging stations, exactly like the precipitation stations, meteorological stations before. Now these are something that I've just put on myself as an example for you, because surprisingly the collection of maps that come from the orange senku do not have a map that shows where the existing stations are. But in your basin, you should begin identifying also where are those gauging stations for flow, who's responsible for them, what's the duration of record that they have, and how can we get our hands on it if we need to. These data sources might become important inputs to modeling that we would do later in the process, and you'll hear more about that from me in Unit 10. Groundwater resources. For orange senku, this map identifies two of the largest aquifers in the basin. Of course, there's the possibility for small pockets of groundwater throughout the basin, but geologically, these are areas of particularly high quality aquifer material. And notice that we've got one in the dry portion of the basin, one in the more humid part of the basin. And in this case, we also have information on what is the recharge rate of those aquifers. Are they replenished regularly with water? And what we find, not surprisingly, is in the more arid west of the basin, the aquifer is actually recharged at a very low level. That tells us that this is an aquifer that's very vulnerable. Perhaps it's fossil groundwater that it contains from previous wet climatic periods, and this is not going to be a sustainable source of large amounts of groundwater to perhaps be used in agriculture rather than diversions from rivers. Whereas here in the east, we find that the groundwater resources are recharged at much higher levels relative to the west, and therefore this might be a more reasonable and a sustainable source of water for different uses, and something that should certainly be factored into our consideration of different sources of water for different purposes. Now, turning our attention to water use, this is an interesting representation of water use. It's one of a few different figures that have been developed relatively recently. I've provided a link for you at the bottom of different ways to visualize the hydrological cycle. Now, we've left the Orange Senku and we've gone to the Colorado River in North America. But what is shown here is the annual flow of the river coming into the graphic from the left. And we can see that a large proportion of that water is abstracted to be used for agriculture. The largest proportion of water from the river is removed to be used for irrigated agriculture. And we can see that the largest part of that water is returned to the atmosphere through evaporation and transpiration. But a portion of it, and actually a relatively large proportion of the whole, is returned to the river through return flow. But that water is used again for storage in reservoirs, for domestic uses, industrial, electricity uses. A portion of that, especially those that are not very consumptive, is returned to the river as well. And so that we have ultimately an export that is a certain fraction of what entered the river reach, in this case the entire river system, at the top. So beginning to distinguish between the water users, agriculture, domestic, industrial, electricity, and the proportions of water that each is using is an important set of information that we'll need in order to understand the context of our flow. Coming back to returning to the Orange Senku and turning our attention to structures, we can see that there are also some hydropower plants that are present. So this is non-consumptive use of water resources, but generally the construction of structures, dams and weirs, that might be having an important influence on flow and storage of water in reservoirs as well. So identifying where those structures are is important, and very often environmental flow assessments will be located downstream of those. This map is showing some different water users and how they're distributed in the basins. The small black triangles that you'll have to see on your own version of the presentation, if you have it opened up beside you, is the location of mines. And we can see there's a lot of mining activity in this river basin, and water use is generally important in mining operations. We can also see the agricultural activities and see how those are concentrated in this particular subcatchment, in the vicinity of the large cities, and in the area where precipitation is high. We can see also some of the urban users. So we can get a sense for the demand that can be expected in different parts of the basin by different users. And we can certainly see that the largest part of the agricultural demand is going to be in this eastern part of the basin. So water, we've got a good picture of water in its various forms of precipitation and surface water, groundwater, how it's distributed in our basin, who are the users, and how are they distributed in the basin. And our attention is being focused into this eastern area where we can expect the highest demands. Those are also the areas with the largest amount of water, and we would expect, naturally, those would have been some of the more complex aquatic ecosystems as well. But let's just look at a couple of other resources relatively quickly. Forest resources are important to consider for a few different reasons. One is that forests tend to be economically very important in river basins. For economic activities, there might be natural forests. Very often they're plantation forests. So there's a key economic link. But also, forests play a big role in the water cycle. Trees are large water users, and especially the choice of tree can influence that. I make a reference to eucalyptus, which is a tree that's being transplanted in many parts of the world where it's not native, and its water use is actually quite large. Now, the effect of having a forest present or removing the forest on the water cycle can vary, and very often a removal of a forest will actually produce more surface water because we've reduced evapotranspiration. But the loss of other services and benefits that come along with that rarely, if ever, justify the loss, justify the small amount of additional surface water that might be obtained. But there's some text to describe the situation here. This is in Kenya. This is the Mau Forest Complex and an important water tower in Kenya as the headwaters of several important rivers, and also an area of very complex socioeconomic issues as Kenya struggles to preserve these important forests. Soils are important. Information about soils, the characteristics of soils, and those portions which are suitable for agriculture. This is where we might find what we expect of agricultural productivity that is already there. It also gives us a sense for what are the potential for growth of agricultural expansion in the future. And soils, like the data coming from those meteorological stations or those river gauging stations, soils are also an important data input to some of the analyses that we may be doing later in the program. So also something to look at in this early phase with an eye toward the future and some of the simulations that we might do. Turning to biodiversity, we're certainly looking for areas of particular conservation value. One system that recognizes that is the Ramsar system of wetlands of international significance. We can see that we do have some of those in the Orange Senku Basin. You might also be focusing on in your own basins, on other conservation areas and unique landscapes that should be preserved. And in the case of Orange Senku, we can also access information about the status of aquatic ecosystems currently. Now note that the colors blue through purple are indicating different classifications of the ecological status of aquatic systems, ranging from still virtually natural to very heavily impacted systems. And we can see that distribution, and we can certainly see an intensification of highly impacted systems in that area of more intensive agriculture, with proximity to some of the large urban areas, as we would expect. Depending on where our environmental activities are developed specifically, we may have the objective of the entire basin, or we may be focusing in particular areas. Areas that are severely degraded are likely to be areas where our objective is some level of restoration, whereas in some of these areas that are still in relatively natural condition, our objective may be to preserve that condition, to avoid any degradation. In some cases, we might find intermediate conditions where we're also just trying to prevent further degradation of the resource. And then for certain systems, we're moving to the Mekong system, and this is the Mekong dolphin. There are individual species that are of special importance, and individually they are targets of conservation and worthy of programs investing in environmental flows and other approaches that might be applied to conserve that species. So you can see an illustration of the idea for developing conservation areas for this particular species in the Mekong. And turning to other species which might not be charismatic conservation targets, but are important for other reasons, fisheries is what I'd like to highlight here. We should be aware of the role of fisheries in the basin, either for providing nutrition to local people and also economic opportunities, or mainly economic opportunities in the area of recreation. And very often the objective one of the most important objectives of environmental flow programs is the preservation of fish species, something we'll also talk much more about during the course. All right, so we've just gone through a wide array of data and information types, and during the situation analysis, that's what we're doing. We're pulling together information. We're learning about the basin. We're trying to understand the context in which we are developing our environmental activities. And I've mentioned that each basin has a past and each basin has a future, so we're interested in determining what are the trends, what are the trajectories of change within the basin where our activities will be located. Some of the areas to focus on there are, of course, what's happening with population. We know that population is at the root of so many of the pressures being put on natural resources. What is the trend in population growth in our basin? Some parts of the world, population is still growing rapidly, while in others it is leveled off. Or there might be just immigration into and out of different areas, even if the overall population growth is not increasing. There may be a redistribution of people in regions. What are the economic development plans? Are there plans for new hydropower facilities, new large irrigation schemes, and the like, which we would anticipate having or increasing or changing demands for water in the future? What about policy and institutional reform? In the case of Kenya, they're actually reforming their policies again. They're trying to decentralize authority even further than it has already been decentralized. So we need to be aware of those plans because they're going to change the framework in which our work will either take place or the fruits of our work will be maintained. And then also related to these, in each case, is some investigation of what are the trends in the use of the different resources, whether it be water, forests, biodiversity, soils, minerals, and the like. Are there plans for greater exploitation of minerals in the basin? Each of these will have an impact on the others, and we want to understand the linkages between them. We also want to use this body of information that we have collected to identify some of the critical environmental issues in the basin, and even through the efforts of our own groups or consultations with stakeholders, begin to prioritize what some of the big issues are. So I've just included some examples here of some of the issues might be that current or potential over-extraction of water, fragmentation of rivers by hydraulic structures may be a problem. Contamination often is. Deforestation, the loss of biodiversity. In our particular basin, what are the key environmental issues that need to be addressed? So let's turn our attention finally, in the last couple of slides, to how we might approach the further analysis of our data to identify what specific responses might be most appropriate for the kind of issues and problems that we've identified. And IUCN, in its documentation, as you'll see, recommends the use of the pressure state response model. I'm also recommending it. It's a very simple framework. It's really a framework to organize our information and to illustrate causal linkages between them. So we recognize that there are a set of activities, generally human activities, but they might also be on natural climate variability or other natural pressures. But there are pressures at work that are influencing the condition of resources and also influencing the condition of human populations in the basin. The result of those influences creates a particular condition or state in the basin at any given time. And the question becomes, what are the appropriate responses in order to either slow the decline of condition, the degeneration of quality of the system, or to improve the condition of people and aquatic ecosystems. So a pressure leading to the current condition of the system, and generally these involve conditions that we are not satisfied with, that we would consider to be problems. So therefore, what are some of the responses that can address them? Now we do this for a few reasons. We do it because environmental flows are not the answer to everything. They're not the answer to all problems. So we want to understand in the larger scope of this basin, in the larger context, what are the different issues? How have those pressures influenced the condition of the system? And what is the collection of responses that are possible in order to improve the situation? Oftentimes, the determination and protection of environmental flows is one and a critical response to the overall issues. But it's always embedded in a larger set of responses that together encapsulate an integrated management of the resource. And even environmental flow assessments themselves very often are not the sole objective of a project, but rather an individual component of a larger development or conservation program. The reading that you'll have for this week from the Pangani Basin in Tanzania is an example like that, where the objectives of the project include a larger set of conservation and development goals, but environmental flows are recognized as a key ingredient in that. And I believe that a lot of you who are working on these issues or on the periphery of these issues today are in a situation like that. So this is just an example of, and I've combined them into just three simple areas. But of course, they can be broken out and explored individually, individual pressures, what the impacts are, or the condition as a result of those pressures in the system, and responses that are specific to those pressures. But it's also helpful to keep them all together so that we understand the complexity. We begin to understand the complexity of the system. So here I've just listed some of the examples of pressures that I had shown in a previous slide as well, the environmental issues slide. Current or potential overdraft, channel fragmentation, water contamination, deforestation, and the like. What are the conditions that result from these pressures? Well, they might be unnaturally dry rivers. We don't yet, in this early scoping phase, know exactly what the degree of alteration of our flow regime is, although we'll know that later as we apply some of our other tools. At this point, we can just see that, and stakeholders can tell us that the river is drier than it did before. It dries up for periods of time when it never dried up before. Things have changed. This is the condition that is clear at this time. Or perhaps there will have already been some research that we're able to access and not have to do ourselves, that also provides a more detailed image of how flows in the river have changed with time. We might be detecting reduced fish catches or the disappearance of species that people in the region can remember that were certainly there before. There might be evidence of water quality problems. Now again, there may be water quality data, as we saw some of it, that just makes these very clear and very specific, but it might be as simple as an unpleasant smell coming from the river, or algal growth and visual evidence of water quality degradation, even if the analyses have not been done to quantify that exactly. And we might find that this is leading to a condition in which there's conflict in the basin. Conflict over the availability of water, conflict over the quality of that water for the different uses that people want to put the water to. And for this set of conditions, there's also a suite of possible responses, with environmental flow protection being one, and as I said, usually a very important one, but also improved water efficiency in agriculture. Think back to the rain-fed agriculture or the water use by plants that I mentioned in the water cycle part of the lecture today. We want, there are responses to improve the water productivity of crops that we're using to reduce the pressure on our surface water or groundwater sources. Addressing the water quality problem may involve new pollution control measures, new enforcement techniques. Policy and institutional reform may be required, and it may be required as well to tackle some of these conflicting situations that we've identified in the basin. Also, there might be a good argument for improving public-private partnerships. Perhaps that's also linked to conflict in the basin. So, very quickly, a simple three-component framework or model can become rather complex. It's represented in a very simple fashion with the arrows connecting the boxes here, but the reality is, of course, more likely to be one of which individual pressures are influencing multiple conditions in the basin, and of course that our responses may also address multiple conditions simultaneously, but rarely will a single response address a majority of the problems. So we're looking at a situation of a multi-pronged, a broader, integrated approach to addressing the issues in the basin, with environmental flows as an important element of that. And that's the situation that you'll be reading about in the Pangani this week. So, just to summarize where we've been during this lecture period together, I hope that I've emphasized that situation analysis is an important and critical early step in the process of environmental flow projects, and oftentimes the larger programs in which those environmental flow activities are contained. Situation analysis is also the point at which we're identifying stakeholders and their roles and developing a strategy for how we're going to interact with them. I've tried to emphasize that our attention should be placed on the condition of people as well as the condition of resources, and also recognizing, of course, that the two are inextricably tied together. And then finally, I've tried to emphasize that there's an analytical aspect to this as well. We gather the data, but then we also analyze the data in simple ways to understand the trends that are occurring in the basin, but also to understand how the issues and the condition and the responses are interrelated, often in a complex fashion. So thank you very much.